Going to look at probability trees. Probably the main thing we've got to add on to what we did last year is a bit of notation. Up the top there with bullet points is things that should be familiar. Each set of branches represents an event. The order of the branches can be tricky. If you know one dictates the other or timing, then you usually can get it right. Sometimes it doesn't matter. You multiply out two branches, that gives you the probabilities as a rule. We're assuming independence there. If more than one branch satisfies the question, add probabilities and so on. Use the complement. If you need three branches, work out the one you don't want and take it away. So this is a simple example. Again, we've got that N notation here, so HNW means home and win. Home, and that's a complement symbol, so HNW not, okay, so a home and something other than a win. So basketball team, so what is the probability of a win? The thing with a win is it can happen two different ways. So we would tend to do this line of working first. So you could win at home, or you could win away from home. Multiplying those two branches out, a win at home, 0.4 times 0.65, and a win away from home, but still winning, 0.3. So we add those together, and we get 0.56. So that's reasonably okay. More importantly, conditional comes in here. Given that the team has won, what is the probability they played at home? Now again, we might have seen this at level 2. We have a formula. It might pay, I'll just knock this into the next page so we can see it all in one hit. So we've got a formula, and we'll get more used to this formula, and this stands for A given that B has already happened. That's what the / means. What's the probability of A occurring given that B already has? So, and if we know that we've got a fixed formula, this is supplied on the formula sheet. We need the intersection A and B on the top and the probability of B, the given condition, on the bottom. So if we juggle it to fit our situation, we're working out, given that they win, what's the probability it's home? Or given that they're at home, yeah. So given that they won, and that's the thing that's stated second after the /, what's the probability they were at home? We can swap the A's and B's with H's and W's, so we need home and a win on the top, which is 0.4 times 0.65. We already worked that out. On the bottom, and what's important to note is that the bottom is made up of all the ways we could win, which is essentially that line of working there, cut and paste and put below, because we worked out the probability you could win. And the top line, and the reason I've written it out this way and not the short way is this. What's important is you'll notice that that part of the bottom line, it's not very good bit of highlighting, is repeated on the top line. So the top line is always a subset, if you like, of the bottom line. I could have written this more simply. I could have just written it. So the probability of a home and a win is, that's 0.26 over 0.56. So that's the other way. That's 0.26 there, 0.56, but that's the final answer. So out of the games that they win, about 46%, slightly less than half of them are at home. So that takes care of the core of that with conditional. Sometimes we've got to work in reverse, and we'd look at that. I'll put an exam question up with a slightly nastier situation that can occur.